All right, I'd like to welcome everybody back to Statistical Analysis in Psychology. This is week 13, class number 2. And today we're going to start up on chapter 9, which is our final version of a t-test that we're going to look at. This time we're going to look at a situation where you need to do the t-test for independent means. So this is our third and final version of the t-test. We've already seen the first two versions, the t-test for single samples, the t-test for dependent means. Now we're going to see the t-test for independent means to complete our look at the t-test. So this is day 4 of our face-to-face shutdown. So thanks for joining me today for this online class. And let's dive in and take a look at the t-test for independent means. So we're going to take a look at a very classic study that was done by Loftus and Palmer that basically revolutionized the way that people looked at memory. So what they did is they were studying eyewitness and eyewitness accounts. And they did a study on whether or not you can change a person's memory for events simply by asking them a question with a certain word in it. Simply by changing the way that you ask a question, can you change what people remember? So we're going to see the results of this and how it revolutionized the idea of memory. But more importantly, we're going to take a look at the t-test that they would have used for this study. And in this situation, we're going to see why the t-test for independent means was the correct one to use. So that's what we're going to be doing today. Before we dive into that, though, we are going to take a look at how to do one-tailed versus two-tailed hypothesis tests in SPSS, specifically how to deal with the p-value when you're doing a one-tailed versus a two-tailed hypothesis test. Then we're going to take a look at doing the hypothesis test with independent means in general. What's the general idea behind it? Then we're going to take a look at how to do it specifically in SPSS. I'll explain the extra practice that I've provided for this exercise or for this lecture. And then I'll just briefly mention the homework assignment that's coming up. All right, so let's dive in with the one-tailed versus two-tailed tests. As we've been progressing through this semester, and last time we made this switch from using t-statistics and t-cutoff scores to using p-values and alpha scores. And the reason for this was to make sure that we could do the entire statistical test simply by going to SPSS, that we wouldn't need to rely on that table of values for the t-statistic anymore. So we came up with these two rules here for when you decide whether to reject or accept the null hypothesis. So if the p-value, if the probability of your sample is less than your alpha level, less than your lines in the sand, then we accept the research hypothesis and we reject the null hypothesis. If, on the other hand, that p-value, the probability of your sample, is greater than your alpha level, your line in the sand, then we accept the null hypothesis and reject the research hypothesis. But this comes with a little bit of a wrinkle, because when we take a look at our outputs here, you'll notice that the significance value, that p-statistic, that p-value for your sample, the probability of your sample, we mentioned last time, that's where you can find it in the dependent means t-test. And we analyzed our two-tailed study using this two-tailed probability. So this was fine when we were doing a two-tailed study and we had our p-value of 0.008, we read that from the table, alpha of 0.05, and because our p-value, the probability of your sample, is less than your alpha level, your probability line in the sand, we decided to reject the null hypothesis. Now, this was the correct thing to do because we were doing a two-tailed test, right? This was the test between the 5-second timeout condition and the 10-second timeout condition. And we were just looking, is there a difference? We were not doing a directional one-tailed test. And this was okay, and it was the correct way to do it, because as you'll notice, SPSS has labeled that significance value, that p-value for our statistical test in this table, it has labeled it as a two-tailed probability. So if we're doing a two-tailed test, that's the correct probability to use. However, we're not always doing two-tailed tests. So the question is, what do we do with this value when we're doing a one-tailed test. How do we adjust this two-tailed significance in order to correctly figure out our sample's probability, our p-value, if we're doing a one-tailed test? Well, the quick answer to that, or the maybe not the quick answer to that, but the first thing you need to know about it is you can't ask SPSS to do this for you. So SPSS will always return the two-tailed value for your p-value, that two-tailed significance, and it's up to you to modify it so that it is correct for a one-tailed test. So how do we do that? Well, it's actually quite straightforward. Since this is the p-value, since this is the probability of your sample occurring in two tails, if we only want one tail, then we simply have to get rid of one of those tails. We simply have to get rid of the probability in one of those tails. And because the probability is evenly distributed between the tail on the left and the tail on the right, to get rid of one of the tails, all we have to do is take that p-value and divide it by 2. So if you're doing a one-tailed t-statistic, if you're doing a one-tailed hypothesis test with a t-statistic, the p-value that you get from SPSS needs to be divided by 2. So in this case, we would take that probability of 0.008 and we would divide it by 2 so that instead of having two tails, we would get rid of one of them and we would only have one tail, and the p-value becomes 0.004, and then that is the correct p-value probability of your sample to use in your analysis. Okay, so again, remember, significance there, always two-tailed. If it's a two-tailed test that you're doing, then you're off to the races. Read the two-tailed significance. That's your p-value. Go ahead with step 5, make your decision. If, on the other hand, you're doing a one-tailed test, make sure that you take that significance, that two-tailed significance, and do the analysis where you divide it by 2 to get to the correct one-tailed probability. And then the last thing that I'll mention about this, and the thing to be very, very careful about, is that we're only dividing the sample probability, that p-value, by 2. We do not touch the alpha level. And sometimes students get confused with this because they're both probabilities. So sometimes they forget, which one should I be dividing? Am I dividing the p-value or am I dividing the alpha level? Try to remember, you don't get to touch the alpha level. The alpha level is important. You can see it in the letter that they chose for it. They literally chose the first letter. They literally said, this is so important, let's give it the letter A, right? Let's give it alpha. So they chose this because alpha is special. Alpha, you do not touch. Alpha, you do not get to mess with. You need way more letters after your name before you can start messing with alpha. So try to remember that. Alpha, do not mess with it. It's your p-value that you divide. So again, if it's a two-tailed test, that significance is for a two-tailed test. You simply read it from the table. If it's a one-tailed test, you need to take that two-tailed probability, get rid of half of it, and that you can do simply by taking the number and dividing by 2. All right, so that was our look at one-tailed versus two-tailed tests, and that applies to every single t-test. That applies to the single sample t-test, the dependent means t-test, and what we're going to take a look at today, the independent means t-test. So let's dive in. We're going to take a look at a demo problem to illustrate the independent means t-test. And this is actually a very, very famous study done in 1974 that revolutionized the way that people think about memory and how memory is stored and the influences on remembering. So let me read the description here. So in 1974, Loftus and Palmer conducted a classic study demonstrating how the language used to ask a question can influence eyewitness memory. In the study, college students watched a film of an automobile accident and then were asked questions about what they saw. One group was asked about how fast were the cars going when they smashed into each other. Another group was asked the same question, except the verb was changed to hit instead of smashed into. The smashed into group reported significantly higher estimates of speed than the hit group. Suppose a researcher repeats this study with a sample of today's college students and obtains the following results. So there we have the means and the number of subjects in the smashed into and the hit group. So you can see the smashed into group has 15 subjects, and the mean speed estimate was 40.8 miles per hour. The hit group had 10 subjects, and the mean speed estimate was 34 miles an hour. So we're going to see, do the results indicate a significantly higher mean for the smashed into group? Use a two-tail test with an alpha of 0.05. So we're going to use a two-tail test with the way that they were asking, is it significantly higher? I would technically say we should use a one-tail test, but just to kind of simplify it a little bit and go with the original way that the question was, we're going to do a two-tail test with an alpha of 0.05. And this was actually what you would have done previous to this study, because you would not know which one of those questions might cause an increase in estimates of speed. But irregardless, let's go forward and see if those scores indicate a significant difference between the speed estimates for the smashed into group versus the hit group. All right, so we have in this case a different situation than we had with the t-test with dependent means. So here we see the kind of situation that we have when we're testing between two populations in the t-test with dependent means, where we take one sample and we measure it, and then we treat that sample and we measure the same people again. That was the dependent means. And the reason it's called a dependent means t-test is because the means for both samples, before treatment and after treatment, condition 1, condition 2, the means for those are both dependent upon the same subjects. So they're dependent upon each other. Contrast that with what we're doing today. Today we got the independent means. And in an independent means t-test, we're not measuring anybody twice. So the nature of the study, the nature of the phenomenon, whatever the reason, we cannot measure people twice. We cannot get valid results if we measure people twice. So in this case, we can only measure people once. So what do we do if we have two conditions and we can only measure people once? Well, we put different people into those different conditions. So that's what we do. We take sample 1 from the unknown population, and then we take sample 2 from the unknown population, and we only treat sample 2. So in this case, we want to know, when we treated that sample 2, did that treatment change that sample so that it now belongs to the treated population, or did it not do anything to that sample, so it still belongs to the same population as sample 1, it still belongs to that original untreated population. So in this case, we're going to be using sample 1, its sample mean, and then sample 2 after treatment. Basically, the bottom line is we have two groups of subjects, each measured one time, and they give us independent samples with independent sample means. So going back to our Loftus and Palmer study here, it's very important to realize that the 15 subjects in the smashed into group are completely different people than the 10 subjects in the hit group. So here we have their scores kind of laid out individually. So these are the raw data. So just bear with me. These subjects were incredibly specific on their speed estimates, for this study. So subject number 1 in the smashed into group said that the cars were going at 43.13 miles per hour. Subject number 1 in the hit group had an estimate of speed of 36.64 miles per hour. Importantly, those are two different subjects. Those are two different people. Those two people are independent of each other, hence independent means t-test. So basically, we have 15 subjects in the smashed into group. We have an additional 10 subjects in the hit group, 25 subjects in total, split between two different groups, and that's what we need this new t-test for this new situation where we have two separate groups of subjects. This is the first time this has ever happened so far in this course, where we are dealing with two completely separate samples with two completely separate groups of subjects. So how are we going to deal with this new situation? How are we going to answer this question? Is the smashed into group, does it have higher estimates of speed than the hit group? Well, luckily for us, it's still the same 5-step research hypothesis test strategy. Still the same 5 steps we've been using since we began hypothesis testing. So let's start off with step number 1. Restate the question as a research hypothesis and a null hypothesis about the population. So we want to know, is there a difference in speed estimates between the smashed into group and the hit groups? So your research hypothesis is that there is a difference. There is an effect. The treatment does make a difference. So we write this as the mean speed estimate for the smashed into group does not equal the mean speed estimate for the hit group. So in this analysis, the hit subjects are the unknown population. They're the original untreated population. You can think of them as the blue population. If the sample that has been asked, how fast were the cars going when they smashed into each other, has now changed so much that it's no longer a part of that hit population, well, it's now become part of the treated population, and that is the smashed into population. So did asking the question change these subjects into this new population, or is the null hypothesis true, that instead of a difference in speed estimates, there is no difference in speed estimates? And the smashed into group, the mean for the smashed into population, equals the same as the mean for the hit population, and they both belong to that original untreated population. So there are your null hypotheses. Research hypothesis, there is a difference. The two population means do not equal each other. Null hypothesis, there is no difference. The two population means equal each other. All right, step number 2, determine the characteristics of the comparison distribution. This one actually gets rather complicated because there's now 2 samples, 2 estimated standard errors, 2 of everything, double the work. Thankfully, not a problem for a computer, and SPSS will do this for you. Step number 3, set a cutoff sample score or critical value. This would require us to go to the table. Once again, for your homework, you'll probably still need to go to the table. However, we are going to move forward with the real world way of doing this, and that is to set a cutoff probability. So your cutoff probability is your line in the sand. It's your probability line in your sand. And this cutoff probability is very simple to figure out. It is equal to alpha. That's the importance of alpha. Alpha is your cutoff probability. So in this case, we have an alpha level of 0.05. That's our cutoff probability, our line in the sand. We're putting 5% in the tails. That's where our lines in the sand are. That's our probability lines in the sand. All right, so we set our cutoff probability. Next thing we need to do is we need to determine our sample score on the comparison distribution. We are also moving away from that, although it will be asked in your homework, so I'll show you where you can find that information. But more importantly for us, we now want to determine our sample's probability on the comparison distribution, and that is the p-value. That is your sample's probability of occurring if the null hypothesis is true. So that's the value that we're going to be looking at to compare to our step 3 probability line in the sand, and very thankfully SPSS will do this as well. So those are the steps that we need to do right now before we can go on to step 5. So let's take a look at how we do steps 2 through 4 in SPSS. So the practice for this, or the data for this, can be found in week 13, class 2 practice, and that is in Canvas for you to download and follow along with. As usual, screenshots of this on a slightly more ancient computer is available in the lecture notes, but we are going to do this live so that you can see, you can follow along, and then you can watch the video later if you need to see it again. So we're going to do this live, and without further ado, let's get going. So if you haven't already, download the Excel file. This is what you're looking for. We're looking for this data here, this eyewitness memory data. Download the Excel file, and if you also haven't already, pause the video and open up SPSS in IU Anywhere. So I already have mine ready to go. So if you need to, pause the video. Otherwise, let's begin. All right, so the first thing we need to do is we need to start putting data into SPSS. So let's start off with the smashed into group. So we are going to copy that. We're going to highlight the scores in Excel. We're going to copy them, and then we're going to go to SPSS, and in the data editor, in the data view, so if you remember these two little tabs down here, we want to make sure we're in data view. In data view, we're simply going to paste those scores in, and that is step number 1. Now, as usual, SPSS has renamed that to a variable name that is wonderful if you're a computer, horrible if you're a human being. So us human beings, we're going to have to do something about that. So we go down here to variable view, we click on that, we click on the variable name, and we are going to call this speed. All right, so these are the estimates of the speed. These are the 43 miles an hour, 45 miles an hour. I think it was going 47 miles an hour. These are the estimates of speed. Notice that it's a numeric data type, so we gave SPSS numbers, and SPSS said, hey, I think you gave me numbers, and we're glad that it thinks that because that's exactly what we did. So there we have estimates of speed. So there are two pieces of information that we need to provide SPSS with. The first pieces of information are the speed estimates, right? What were the speed estimates? What were the raw scores? What did the subjects say about how fast the cars were going? But there's a second piece of information that we need SPSS to know about, and that is what sample do these subjects belong to? So this is the first time that we have two samples. This is the first time we have subjects that could belong to either the smashed into group or the hit group. So what we're going to do is we're going to remember that rule that every single subject gets one row in SPSS, one row and only one row. So in that case, if we want to tell SPSS what group these scores come from, we're going to go to column 2, and we are going to write in smashed. We're going to name this group, and we're going to name this group smashed. So we're going to copy and paste that all the way down, and then basically let SPSS know that these are the scores from the subjects in the smashed into group. So subject number 12 here, subject number 12 had an estimate of 48.49, and their group belonging, their group identity was the smashed group. So that's everything we know about subject 12, all on that one line, right? So everything about subject 12 has to go on that one line, including their speed estimates and the group that they belong to. All right, so now we have the smashed into group. We're not going to keep this as var 00002, so we go back to variable view. We go up here to var 00002, and we're just going to call that group, right? Which group are you part of? And notice that SPSS has labeled this as a string variable. It's labeled it as a word. It has basically told us, oh, you gave me a bunch of words, and we're happy that it thought that because that's exactly what we did. All right, so we have this smashed group completely done, right? They are completely ready to go. The next thing we need to do, though, is we need to put in the second sample, right? We need to put in the hit subjects. So for that, we go back to SPSS, and we highlight the raw scores, the speed estimates for the hit subjects. We copy those, and we remember that these are 10 new subjects. These are 10 completely new subjects, and they need a place in our data editor here. And new subjects have to be put into new rows because every subject only gets one row. So all of these rows are occupied. So we're going to go down here and we're going to paste their scores into these all new rows. And we are also going to go here, and then we're going to need to label these in terms of what group do they belong to. So we're going to call these ones the hit group. And we're going to fill that in all the way down. So now we have the hit group, we have the smashed into group, we have all the raw scores. This is a properly formatted data set for the independent means t-test. So now that we have it properly formatted, what we're going to want to do is we're going to want to go up here to analyze. We're going to want to go to compare means. So this is where we've been camping out this last little while. Analyze, compare means contains all of the t-tests that we want. And then we're doing an independent means t-test, and we need to find something that looks like that. And SPSS is being very friendly again, because it is calling this, instead of an independent means t-test, it's calling it an independent samples t-test. Independent and independent works for me as in my human mind. One thing to note, do not fall for the summary independent samples t-test. It's only the independent samples t-test. So we're going to click on that. So once again, you go to analyze, you go to compare means, you go to independent samples t-test, you click on that, and then you get this dialog box here asking you to specify some things for SPSS. All right, so we have the independent samples dialog box. The first thing we need to do is we need to tell SPSS what are the test variables. The test variables are basically where your raw scores are. So SPSS is asking us, hey, where are these estimates of speed? Which one of those two variables is your estimate of speed? And you'll notice that if you try to put in the group variable, SPSS will tell you, no. Words are not allowed in this list of variables. I need something with numbers. I need something that is numerical. So if you get that warning, that means that one of two things might have happened. Either you tried to put the wrong variable into the test variable box, or SPSS thinks that your numbers are words, in which case you're going to have to delete the entire column, click on the tab, delete the entire column, and or click on that header, delete the entire column, and start all over again. But in this case, we just tried to put the group into the test variables. That was a wrong one. We need to put the raw scores, the speed estimates. So we click on that, we pop it in, and lo and behold, SPSS is completely fine with it. All right, so the next one down here we need is the grouping variable. Not surprisingly, this is where we have group. So we're going to put this in here, and notice that as soon as we do, SPSS says, all right, you're calling this thing group. I got two questions, right? 2 question marks. I got 2 questions. What are the names of the groups? It's an independent t-test, sample t-test, so I know there's 2 groups. That's why there's 2 question marks. But what are their names? So we're going to go down here to define groups, and we're going to enter in the group names exactly as we type them in. So we're going to enter them in exactly as we type them in. So what I'm going to do first is I'm going to do it correct. So we called one of these, as soon as I said that, we called one of these smashed, if I can spell it. So we called group 1 smashed. We called group 2 hit. And that's what SPSS needs to know. So we fill in the name for group 1, we fill in the name for group 2, we hit continue, and then once we have that set, we hit OK, and SPSS runs our analysis. Now, before we go to looking at that analysis, before we go to analyzing it and breaking it down and finding out where everything is, I want to show you just what can happen in this particular analysis here. So let's say that we go back here. Let's say that we're running this t-test, and you go to analyze, you go to compare means, you go to independent samples t-test, and you're down here defining your groups. And let's say that instead of smashed, you put smash, right? Once again, to our human minds, smashed, smash, you know, potato, potato, we can make that mistake. If you put in smash and hit continue and hit OK, SPSS will give you this output right here. SPSS will tell you, warning, the independent samples table is not produced. And it'll take you down to this group statistics table here, and it'll tell you, look, I found 10 subjects in the hit group, but you got nobody in the in the smash group. You have nobody at all in the smash group. So if SPSS cannot run a t-test, that means that you have set it up incorrectly. And probably the best idea, rather than trying to fix it, is just delete the whole data set and start on over. Because oftentimes it's very difficult to pinpoint exactly where you went wrong. This one's a little bit easier because I intentionally made this mistake to show you. But you can also get clues from this group statistics. It's telling you there's nobody in the smash group. So you would go back to SPSS, back to the data editor, and you would take a look at the names of your groups, and you would realize, oh, I called it smashed. I didn't call it smash. Of course, SPSS couldn't find anything. So we go back to analyze, we go back to compare means, we go back to independent samples t-test, we define our groups, we call them exactly what we named them when we entered in the data, we hit continue, We hit OK, and lo and behold, SPSS can run our hypothesis test. All right, so that was a live demo of the independent samples t-test. Now let's take a look at exactly how to analyze this. So we got a bunch of numbers. Once again, this is the same table. It's just got some differently formatted lines in there, so don't let that throw you off. But we are done with the SPSS setup and the SPSS analysis. And now what we need to do is we need to find the answers for steps 2 through 4 so that we can answer step 5. So we can get to the point where we can decide whether to accept or reject the null hypothesis. And remember that we do have those old rules that you can still use, especially for your homework. You're going to have those cutoff scores anyway. So if your sample t score is beyond the cutoff t score, accept the research hypothesis, reject the null hypothesis. Or if the sample t score is within the cutoff t score, accept the null hypothesis and reject the research hypothesis. And remember, draw out your distributions. I know we're doing this online, so I really can't draw things out for you. But make sure that you're drawing out your distributions. Remember that within means within the body, and then beyond means inside the tails. It crosses over into the tails. So we're moving away from that, though. So that's for your homework. But in real world, in real life, and on the exam, we're moving away from that. So we're dealing with these rules. They're equivalent. They're exactly the same because t-statistics and probabilities are interlocked. But we're dealing with probabilities now. So if the p-value, your sample's probability, is less than the alpha value, your lines in the sand, we're going to accept the research hypothesis and we're going to reject the null hypothesis. If, on the other hand, the p-value is greater than our alpha level, our probability of our sample is greater than our lines in the sand, we're going to accept the null hypothesis and we're going to reject the research hypothesis. So let's find all that information that we need. Let's zoom in a little bit here so we can see. And what we're going to start with is we're going to start with that top table. We're going to start with that group statistics table. And you always, always, always want to start with this table because it will let you know if you made any horrible, horrible mistakes when you are entering in your data. So it is always worth double checking this because SPSS will not tell you that you made a mistake copying and pasting data. SPSS will not tell you that you made a mistake labeling your groups. It's up to us to check. So SPSS will tell you what it did, but it's up to us to check to make sure that that's what we wanted it to do. So we go to that top table, and it's labeled the two groups. So the upper row is smashed, the lower row is hit, and then SPSS lets us know how many scores it found in each of those groups. So it had 15 scores in the smashed into group, and that's great because we had 15 subjects. That's exactly what we want. SPSS is saying, oh, I found 10 scores in the hit group. Also great. That's exactly how many subjects it's supposed to have found. So that gives us confidence that we have entered in that data correctly. We can then check the mean. So we have calculated in Excel the mean of the smashed into group, and the mean was 40.8. SPSS is saying that it calculated those scores and the mean for those scores and found the exact same mean, giving us confidence that we entered in the correct scores. And similarly, for the hit group, SPSS says that it found an average of 34, and we double check with Excel and we see that it actually does have an average of 34, once again giving us confidence that we've entered it in correctly. Make sure that you double check that first table, because if you got that wrong, if there is something weird, if there's something off, if they said, oh, if SPSS told us, I only found 14 subjects in the smashed into group, that means that everything that follows is going to be wrong. So make sure that you have everything on point. Make sure that you got all your ducks in a row before proceeding, because you can do all the hard stuff. You can do steps 2 through 4 and do step number 5 right, and it doesn't mean anything. And in the real world, it can actually be extremely harmful if you've entered your data incorrectly. So check your data, get into that habit, make sure that you just do that little double, triple check, make sure that you have entered in your data correctly. And this is something that'll become very important in an exam situation especially. So if you're dealing with an exam situation where it's a bit of a time crunch maybe, and you're under a little bit of pressure, and it's easy for fingers to slip on a keyboard, that's going to save you a lot of grief if you just happen to make a very human error and entered in your data incorrectly. All right, so we've double checked, we're all good, we're good to go. So off we go with step number 2, determining the characteristics of our comparison distribution. I mentioned that SPSS will do this, so all we need to know is where can we find that information. So we are now going to move to that bottom table labeled independent samples t-test, and you can see that there's 2 rows there, and the one that we're going to only look at is the equal variances assumed. So they have a row called equal variances assumed. They have a row called equal variances not assumed. In Introduction to Statistics, you learn about equal variances assumed. In your graduate school work in statistics, you'll learn about equal variances not assumed. So because this is the intro, we're going to stick to that top row. In the real world, most of the time, you're going to stick to the top row. In graduate school, you'll find out why you're going to stick to the top row. But we're going to keep it as simple as we can. We're going to stick to that top row, equal variances assumed. All right, so we have this entire row of data. That's what we're going to be looking at, that equal variances assumed row. So where can we find the information for the characteristics of our comparison distribution? First thing we want to know is how many degrees of freedom does this comparison distribution have? And SPSS has very nicely calculated that out for us. Our comparison distribution has 23 degrees of freedom. The next thing we need to know is what is the spread of our comparison distribution? What is its standard deviation? What is that estimated standard error? Now, this was where SPSS gets a little tricky, because as you can see, there are 2 places where we have the standard error labeled. We have standard error of the mean up in the group statistics, up in that top table. So that final column in that top table has 2 numbers for standard error of the mean. And then if you look in the bottom table, in the 3rd column from the end, we have standard error of the difference. Which number do we need? Well, make a note of it. That's the number you're looking for. That is the standard deviation of your comparison distribution. So this is where you can find the degrees of freedom and the estimated standard error, those 2 pieces of information that you need for the characteristics of the comparison distribution. So that is step 2 in the books. All right, step 3, set a cutoff probability. Just to reiterate, that is your alpha score. If you don't remember it, go back to the question, read it. It's usually one of the last sentences that says, you know, use an alpha of whatever. We got to find out what that whatever is, and this time it is 0.05. All right, step 4, determine your sample's probability on the comparison distribution. So we need to find that p-value. We need to find our sample's probability if the null hypothesis is true. And luckily for us, SPSS will do this. So I mentioned that you'll also have to find your cutoff score, your sample t statistic for your homework. So I'm going to show you where to find that now. But basically, just so you can kind of see where it comes from, SPSS calculates the mean difference between the 2 samples, and then it divides that by the estimated standard error. So there's your mean difference between the 2 samples. It was a 6.8 miles per hour difference, and that causes your difference to have a t statistic of 2.628. So that's where you find your t statistic. It's labeled t. That's your t statistic for your sample. So in your homework, you don't have to calculate that out by hand. SPSS will do it for you. That is your t statistic for the independent means t-test. All right, so we found our t statistic. If we were using cutoff scores, if we went to that t distribution table, then we would compare this t statistic to our cutoff scores. However, we're doing this with probabilities now. So we need to find our p-value. We need to find the significance of our sample. We need to find that probability of our sample occurring. And once again, SPSS gets a little bit tricky, because if you look in this independent samples t-test, you'll notice 2 columns that are labeled with SIG, S-I-G, right? One of them is the 2nd column with a SIG of 0.39, 399. The other one is the 5th column with a sig two-tailed of 0.015, the one that we want is that two-tailed significance. That's the one that we're looking for. The other one is a completely different test. We're doing a t-test. That's the significance that we're looking for. So our two-tailed significance is 0.015, and that's what we're going to compare to our alpha level. So again, make a note where to find this, know exactly how to read these tables. There's a lot of information on them. So as you're kind of progressing, make sure that you're highlighting and making little notes so that you know step by step where can you find all that information. So now we got step 4, on to step 5. Now we are ready to make our decision. So decide whether to reject the null hypothesis. If the p-value is less than alpha, we're going to accept the null hypothesis and we're going to reject the research hypothesis. If you recall, our p-value is 0.015. Our alpha level is 0.05. That means that our p-value is less than our alpha value. That means this is the decision we're going to make, accept the research hypothesis. If, on the other hand, our p-value was greater than our alpha level, we would do the opposite. We would accept the null hypothesis and we would reject the research hypothesis. So once again, just to reiterate, we're doing a two-tailed t-test. That's our p-value for two tails, so we can read it straight off of the table. So comparing the two of them, the p-value, our sample's probability is 0.015. Our alpha level is 0.05. Alpha is larger than our p-value, so that means that we reject the null hypothesis, and the conclusion is that the smashed into group had a higher estimated speed than the hit group. So once again, this revolutionized our understanding of memory. People always thought that memory was sort of like locked away and remembered and just like a file that you could read. And this was one of the first demonstrations that it's malleable. It can be changed because all of these students had the same memories, but the ones that were asked how fast were the cars going when they smashed into changed their memories in a different way when they accessed them compared to the ones that were asked how fast were the cars going when they hit each other. So very revolutionary study, changed the way we thought about memory, changed the judicial system, and as we can see here, was done and the correct conclusion was reached with an independent samples t-test, much like the one that we did today. All right, so that's our new information for today. We got one more day that we're going to spend with the independent samples t-test, basically going through exactly when do you use all three of these t-tests, like how do you decide which is the one that we're supposed to use. But that's going to happen next class. For right now, let's wrap this up. So just to keep it on your radar, make sure that you continue to do your MyStatLab study plan, especially now that the pre-tests are getting a little bit more challenging, especially now because some of the pre-tests might require that you use SPSS and you haven't been taught that before the pre-test. I understand this. The value of the pre-test is still there. The value of the pre-test is in the struggle, but just to make sure that we're getting those awesome learning objectives without harming your GPA, remember that you can get 100% on your pre-test, substituting in your MyStatLab study plan, earning those mastery points. And then as well on this, there is extra practice. So there are a few more t-tests that you can try out in SPSS. The data can be found in the Excel sheet that we just used. And then the questions and answers can be found in week 13, chapter 2 practice, chapter 9, the t-test for independent means PowerPoint. So this is this file right here. All right, and it has all the information that you need to start the test. And then it also has the output that you should be looking for, as well as the answers to every single step in that 5-step procedure. So give those a shot. And if you are having difficulty with those, absolutely drop by an online office hour, check Canvas for the Canvas announcements or the Canvas modules for the links to that. And make sure that you are practicing these skills because they are, again, skills that will take a little bit of doing before they become very automatic. And that's what we want to do, get to the point where it's extremely automatic. All right, so there's your extra practice. And then finally, homework assignment number 12 on chapter 9. You are ready to go for the independent means t-test homework. And that's going to be due April 15th by midnight. So make sure that you have that on your schedule and get your practice in, get your homework done, and learn all about how to do this very useful, very often used in psychology t-test. All right, so that is it for today's class. Thank you so much for joining me for this online session. And next time, we're going to take a look at how can you decide when you're supposed to use all three of these t-tests. But that's it for today. So thank you for joining me. Take care of yourself, and I will see you all next time.